This week we're looking at models with level 2 predictors. And that means that we have predictors that are specific to our clusters, but not to our level 1 observations. We also call these types of models means as outcomes models. As a lecture, we're going to look at a model with activity predicting positive affect from the pain dataset. So one way to think about this is that our level 2 predictors have no level 1 variability. So they can't help us predict variations within clusters, but they can help us predict variations between clusters. They can explain our cluster means, but they don't change how much our cluster means explain total variability. Another way to think about this, where instead we're thinking about it in the model notation terminology, we have this new gamma 0, 1 parameter, which is the slope on activity, and that helps us account for some of our level 2 variability, which is sigma squared mu. So now sigma squared mu becomes smaller because we've accounted for some of that variability, and it's now a residual that's left over. It's the residual variability between clusters. But our cluster means are still the only thing that's actually helping account for our total variability. So our level 1 residual, sigma squared epsilon, remains unchanged. Getting over to R, we can fit our model using LMER from the LME4 package, just like we did with the unconditional model. And this looks a lot like a LM object or an AOV object, except we have the one vertical bar ID variable part that we talked about last week. So here I've loaded the data, I've loaded my LME4 package, and this is what the model syntax looks like. So I have P affect being predicted by active plus one vertical bar person ID. And we can review the results of our model with the summary function as before. In this case, I'm actually saving the summary object to an object of its own that I can refer to later, and there's a reason for this that I will show you. And again, I'm printing it out while I'm saving it by putting everything in parentheses. And this is all a little cut off. These outputs get pretty big. They're too big for these slides. So I'm going to jump over to my R window and take a look at the summary from this model in the R console. So here I will print it out for you. This way you can see what it looks like. So here we have the model being read back to us again. As we had before, we have convergence criteria, scaled residuals, don't worry about those. And we have the random effects table. So this is very similar to what we saw in the unconditional model. There's no new parameters there. Then we have the fixed effects table, and this is again similar to what we saw in the unconditional model, but now we have an additional parameter for activity, and the estimate is the gamma 0, 1. This is the slope of active on our outcome P affect. And then we have a correlation of fixed effects. Now that we have more than one fixed effect, it also gives us it'll give us a full correlation table. In this case, we only have one fixed effect, so it's correlating it with the intercept. Now, if we want to just break down parts of this output, we can do so with some functions. And this is why I saved the summary object like I did before. So note that I'm calling the coef function on the summary object. I saved the summary as summary active, and now I'm calling coef on that, and that's giving me the fixed effects table, and it's letting me just extract that. And you may be looking at this saying, we have a standard error, we have a t-value, where's the p-value, where's the degrees of freedom? Well, to find that out, you'll have to tune in next week. In the meantime, we can go back and review our random effects, and this is just like we looked at with the unconditional model. We can use the var_core function to extract these. And as before, you can print them and then use the comp equals variance to have it printed in variance units. Also notice that if you actually output the var_core function call as a data frame, if you call it as data frame, it will give you the variance as under this vcove option. And this is a little bit useful to know because when you call it as a print object, you can't actually save this as something, you can't save this as something you can refer to inside of R, but you can do that with the as data frame call. So with this, you can, if you wanted to refer to this 1.65 directly, for example, by saving a data frame with this table. You could do that. You could save this table, and then you could call an object from inside the table. But not that important. It's just another thing that I noticed. And so that's all we really need to look at in terms of the LME4 syntax for fitting the models. In the next video, we're going to look at R squared, and that gets a little bit more involved.